we have another refactor to do here. I have a get top stories method. Like we saw earlier, this returns a type of task, a frozen model of story models. And if you've never heard of frozen sets before, these are pretty cool. This were introduced in .NET 8, and it's very similar to an read-only list or immutable list or immutable collection. But the difference with frozen set is it actually is frozen. Again, if you've used C# long enough, you might know that even if it's an iRead-only list, a user can still edit the values that the indices of that list are pointing to. So if that list has 5 things in it, I can look at what's in position 1 in that list, and then I can change the value under the hood. And likewise with immutable lists, there's funny things we can always do to get around that. Whereas with frozen sets, you can't. Now, be careful with frozen sets. I'm using them here in my .NET MAUI app because there's only ever going to be one user of my mobile app. And I'm a big fan of immutable collections. So I always recommend that anytime we get a value from an API or a database, something from outside of our control, to keep that immutable, whether it's put in a record, whether it's put in an immutable list, an iRead-only list, or a frozen set. I like to ensure that that data that comes back remains pure and unchanged. So that's why I'm using a frozen set here. But be careful with frozen set because it does have a big performance hit. If we were to say return an iRead-only list here, to list, there we go. So if we were to return this as an iRead-only list, this would finish about a millisecond faster than with our frozen set. So in my case, there's only one user that's ever able to use my app simultaneously. And I ran the benchmarks against this to ensure that the performance hit from creating a frozen set wouldn't impact my user. And when I found it was going to be 1 millisecond, well, I'm okay with that for my mobile app. But again, be very careful using this in, say, ASP.NET Core APIs, because you don't want to constantly be spinning up frozen sets every time, say, a user makes a GET request to your API, if you don't have to, because it will be a sizable performance hit. But anyways, we need to refactor this method. So let's look at it. We've got our get top stories method, where we first get the top story IDs, and we're calling configure await false, so that's great. And then we take those top story IDs and we put them in a for loop, or rather a for each loop, where for each top story ID, we make another API call to the Hacker News API service to get that story. Now, there's a couple things I don't like about this method, but I do like the fact that we're already using async await. I like the fact that we're using configure await false because this code never touches the UI thread. So why would I ever want to return to the calling thread? So let's take advantage of configure await and those performance benefits. But one thing I don't like is the fact that I'm calling get story one at a time. So I get all my top story IDs, and we can see that my story count here is the int max value. So we're getting back, what's that? 1,000, million, 2 billion stories. I don't think Hacker News has 2 billion stories, but this would fetch 2 billion if we let it. We have to call each story individually. Well, what would be way better is if all these stories were being, or rather all these API requests to get the stories were being made in the background in parallel. So what we can do here is instead of iterating over each of them by themselves, let's create a list of task of type story model. And let's call this get top story. Perfect. Get top story tasks. There we go. And what we're going to do is we're going to say, we're going to call get story, but let's do it like this. Let's say top story IDs dot select. And let's say that we want to call get story and pass in that ID along with our cancellation token. And then we'll call toList to turn this into a list of tasks. So what we're doing here is we're calling get story for every ID that we retrieved from getTopStoryIDs method. If this looks a little funky to you, I do want to show you that this is also the same as doing something like this. We could say getTopStoryTasks.add, and we can say getStory for that top story ID. So this code is essentially the same as this code here. We're just getting red squiggles because we're reinitializing the variable twice, but .select is under the hood creating a for each loop for us, or rather creating a for loop on our behalf, where it is iterating through the top story IDs and doing this. So whichever one is clear to you, whichever one makes the most sense, go for it, keep it. But for now, let's get rid of those red squiggles. There we go, much better. Okay, we've kicked off a task, a background task for every top story that we've just retrieved. So if we're getting 100 top stories, we now have 100 tasks spun up, making API calls on background threads. And what we can do is we can get those results by just saying await task.winAll and passing in our list of tasks. Because task.winAll will wait until every single task in this list has completed, and then it'll return that value for us. And in fact, I could just return these top stories as a frozen set, and this is totally valid code. Now, I like this. I like what's going on here, because instead of making each API request one by one and waiting until the previous one finished before moving on to the second and the third and the fourth, we can now get this top stories much, much faster. But this still is not a great user experience, because what's going to happen is the user's just going to see a spinning indicator on a white blank page. And then once I've finished getting all the stories, maybe that takes 5 seconds, boom, every single story will appear all at once. So for 5 seconds, the user's just staring at a blank app. So instead of forcing the user to sit and stare at a blank UI for 5 seconds just watching this activity indicator spin, we can take advantage of a cool tool in C# called iasync enumerable. And let's actually get rid of frozen set. We'll just return an iasync enumerable of type story model. And let's get rid of this code down here. And we'll circle back to get these red squiggles in a second. But you'll see I have another red squiggle up here because I'm getting yelled at that getTopStories is not a method I can just use with the await keyword anymore. So what this does, what iasync enumerable does, is it gives us the ability to use the await for each loop. So if I say var story and getTopStories, there we go. And now, because I'm iterating over each top story up here, I can move my logic from this for each loop into this for each loop and blow this away. And yeah, you know what? We should probably, I'll just clear that collection before now. So what's happening now is that every time one top story completes, so before we were waiting for all 500, all 2 billion, however many top stories we were getting to complete, while the user's just staring at a blank activity indicator. Well, now what iasync enumerable allows us to do is, as soon as a API request is finished, as soon as this getStory method has completed, well, that value is available to us, and the await for each loop will now surface that to us. And as soon as that information is available, we can display it to the user. So we'll still have the spinning indicator, but now as it's spinning, this is how we enable the behavior we see here in the finished app, where the stories start rolling in. And again, the user is not just staring at a blank page. So we get a better user experience. And this is also a way we can trick our users a little bit, because when you're just staring at a blank canvas, a blank screen for 5 seconds, that 5 seconds is going to feel like forever. But if we distract the user by showing them the information as it is coming in, as it's available to us, well, the wait time doesn't feel as long. So while both of these implementations might each take 5 seconds, the user's not going to feel like this implementation with the await for each loop took that long. Okay, now how do we surface each story once it's ready? Well, before we were saying task.whenAll, right? Just wait for everything to finish before we can return the results and show them to the user. Well, there's a really, really cool, really, really powerful API in .NET 9 called whenEach. And you can even see here, whenEach uses an iasync enumerable. So with whenEach, because it's an iasync enumerable, just like we learned a second ago, that means we want to use an await for each loop. So we'll say var top story in task.whenEach. And here we'll say yield return top story, but not yet, because task.whenEach returns us back the actual task. So instead of top story, let's call this top story task. And we'll say await, and we'll add in a configure await false. This await configure await false might feel like overkill because we know this task is completed. So whenEach only returns a task when it's completed. So in this really rare case, it's totally valid for us to just say yield return top story task.result. But I kind of said earlier to never use .wait and to never use .result. Even though here it is absolutely valid because we know the top story task is completed running and we can just get the result from it. But the reason I still say don't use this is this code's going to change someday. Eventually, a new engineer is going to join the team. They're going to copy paste code that they see from the senior engineers into different places, and they're going to refactor it. Eventually, this .result is going to leak out into your code base once somebody copy pastes it and uses it somewhere else. And then all of a sudden, they'll point to you and say, oh, well, Brandon said .result was valid here. So because of that, I still highly recommend just saying top story task and saying configure await false, even though we know the task is completed, because after looking at the compiler generated code, we know that we're not actually going to switch threads here. The task is already completed. So the await keyword is just going to grab the result anyways. And again, even though we know that we're not going to switch tasks and we don't need to worry about what thread we return to, there's no need to worry about that because the task is already completed. But again, eventually this code will leak out somewhere into your code base. And because of that, I always still recommend using configure await false here as well. Okay, now we do need to clean this up a little bit because there's squiggles everywhere that I'm getting yelled at for. So the first thing is, here in iasync enumerable, we are passing in a cancellation token, but it says, hey, just so you know, you're passing in a cancellation token, but you didn't decorate it with the enumerator cancellation attribute. So to quickly show you how to get rid of that squiggly bracket, shoot, what's the name of the attribute again? Enumerator cancellation. So I'll put the enumerator cancellation here. And what enumerator cancellation does is it actually tells .NET to take our token, the one that we're passing into our method, and actually pass this into the iterator in the .NET runtime. So if you've ever used a IEnumerable before, similar logic,